Integrated 3 students, it's the end. It's the last day of Integrated 3 that we'll ever get to do together. So we'll start off with number 4 because I kind of want to count it down to number 1. So starting with number 4, fourth most important thing that you need to remember for the ACT for any future math class, the so-called powers of 2, all right? Very important. Simply start off with 2 to the first, because what are we talking about? We're talking about 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. So what's 2 to the first? 2. All right, put a 2 and a comma. 2 squared, 4. 2 to the third, 2 cubed, 8, of course. 2 to the fourth, 2 times 2 times 2 times 2 is 16. Or do you remember you're just doubling the last number, right? When you take 2 to a power, don't you just keep going times 2 times 2 times 2 forever? It's actually an old geometric sequence is what it is. But more importantly, it's knowing off the top of your head what is 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. That comes up on the ACT. And it comes up in my calculus class as well. 2 to the fifth. Just double 16. Just keep doubling. 32, all right? There's your first 5 powers of 2 right there. Mr. Wade, are the powers of 2 that important? Yes, they're on the ACT, they're on the SAT, they're gonna be in all these future math classes. Why else are they important? Real life mathematics. How many times in class did we talk about doubling? The cockroaches, the spider infestation in that one house in Missouri, remember? The snakes, the bacteria doubling, right? All this stuff in real life that we talked about, right? DNA, ancestry, all has to do with doubling and halving and things like that. Remember this? Okay, let's keep going. 2 to the 6th, you need to know. Well, just double 32. Double 32, 64. You may have to write really small to fit this in the box, I noticed, by the way, or make it like in two different layers. All right, 2 to the 7th. Well, 2 to the 7th is just double 64. Double 6 is 12. Double 4 is 8. 128. Very important number in math. All right, let's double that. Double 128 is 200. Double 28 is 56. That's also our perfect square 16 squared. You need to know that one too. All right, and that is 2 to the 8th. 2 to the 9th, double that. 250 doubled is 500 plus 6 doubled is 12. 500 plus 12 is 512. It's all about the mathematical mind tricks I taught you. And finally, double 512. 2 to the 10th. Okay, so 2 to the 10th is equal to double 5, 10. Double 12, 24. They can even ask ACT questions where if you knew that 2 to the 10th was 1024, you could just cut to the chase and answer the question in 2 seconds instead of 5 minutes, for crying out loud. So those are your first 10 powers of 2. Please know those. They're so important. Or just be able to double really fast in your head. That's fine too. All right, third most important thing from the year that you will see over and over and over again, be able to recognize a number as, hey, you're a perfect cube. Be able to just look at it and know. So what are the first 7 perfect cubes? All right, 1 to the third is 1 times 1 times 1. Obviously 1. All right, 1's a perfect cube. 2 to the third, 2 times 2 times 2. 8, we just did it earlier. 8's a perfect cube, right? You have to look at 8 and just say, oh, that's 2 to the third. I bet that's why it's there on the ACT unless it's some kind of random problem. 3 to the third, 3 times 3 times 3. 27. 4 times 4 times 4. 64. All right, 5 times 5 times 5. 125. Now we get to the biggest ones that you should know. I have witnessed in my career non-calculator problems where they expected you to know 6 times 6 times 6. 216. That's as high as we ever went in integrated 3. And maybe one day I casually mentioned what the next one was because some of you overachievers are like, hey, Mr. Wade, can you tell us 7 cubed just so we know? I have seen an instance in calculus where you had to know 7 cubed off the top of your head, and it's 343. Or even better, what it was they gave you 343, and you had to recognize, hey, you're 7 cubed, or you couldn't solve the problem unless you recognize that. And it was a non-calculator problem on the AP test. So that's kind of the max for you overachievers right there, all right? I've never seen a case in college where you need 8 cubed, 9 cubed, or 10 cubed without a calculator. But I would know these right here, okay? Very important. And it'll make ACT problems easier as well. I said the buzzword again, ACT, right? ACT, 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 ACT. All right, so important. Now, second most important thing of the entire year, the next 6 perfect squares after 100. Know those. I know all of you know your perfect squares up to 81 and 100, and then we got to know after this. Okay, because all of my classes, I mean, you just aced all these perfect squares off the top of your head, no trouble. You got to know 11 squared, 121. You've got to know 12 times 12 from 3rd grade. It's like the very top of the times tables, 144. Now, let's go above and beyond the times tables. You must know that 13 squared is 169, or you will get stuck in math classes and in college on non-calculator problems. And the people that don't know this is 13 times 13 are just stuck. There's nothing you can do. There's no way out. 14 times 14, you must know that this is 196. Remember the old switcheroo right here? Okay. 15 times 15, 225. And I'll draw a little extra bar. Finally, 16 times 16 is 256. And if you know up to there, you're pretty much invincible. ACT, SAT, colleges that now most of them say no calculators, sorry. So now you're set. And the thing I've rated the #1 most important topic from the entire year of Integrated Math 3, before you go to pre-calculus and calculus and take the ACT or SAT again, you must know your primitive Pythagorean triples, life-changing. And even some of you confirmed this year, hey, I went and took the ACT, you were right, Pythagorean triples are everywhere. And just know the primitive ones, all right? The primitive ones are the ones where the greatest common factor is 1. They don't have any common factor with each other except for 1. What's the easiest Pythagorean triple you all know? 3, 4, 5, of course. We'll put that in the first box. So 3, 4, 5 is a Pythagorean triple because 3 squared plus 4 squared happens to equal 5 squared. They even knew this back in 1800 BC. All right, now, what are some other primitive Pythagorean triples? 5, anybody? 12, anybody? 13? 5, 12, 13, right? So important. All the time they use it in the ACT and SAT. Now, 5 squared plus 12 squared is 13 squared. True. Also, primitive Pythagorean triple, because no number goes into 5, 12, and 13, except for 1. Another primitive Pythagorean triple, 8 something. 8, 15, 17, all right? And then one more that you should always know, 7, 24, 25. And the extra above and beyond that I gave you in class for the overachievers, I said, if you want to go ahead and file this away in your brain, you can. 9, 40, 41 is the above and beyond, all right? Sometimes I'll throw that on the ACT, but they pretty much use these. Now, one more thing, don't forget, they might also use multiples of those. Just know your primitive triples, and then you can always adapt to the multiples like we did in class. So like for instance, this is not a primitive triple. If you see like a 10 and a 24 in the ACT, which they love to put that on there, just realize, oh wait, I know my 5, 12, 13. 5 has been doubled. 12 has been doubled. Find the missing side in the ACT. 13 times 2 is 26. So like 10, 24, 26 is a multiple, but you don't have to memorize that. Just know these, and you can always get to there, right? Okay, and I'll make this one final note. One of the most common triples on the ACT that's not primitive, but a multiple. Now I want you to follow my directions very carefully as you write this down because I have a little special surprise for you here. So way back at the beginning of the school year, when we thought this was going to be a completely normal school year, which apparently it was not, the craziest one ever, right? The very first number we ever wrote down on day 1 of integrated 3 was the number 1. That's where we all started together. So I want us all to write down the number 1 last. We're going to end the year where we started, all right? So as we were all getting acquainted in August, except for the ones I already knew from integrated 2, but then there were all these new faces and we got to be good buddies in a few weeks. First digit was 1. The most common multiple of a triple on the ACT is simply double the 3, 4, 5. They use it all the time. Now write this down with me at home. 6, comma, stop right there. 8, comma, hold on. If you write the 0 first and then go back and put a 1 in front of it, you can end off the year writing the digit 1 just the same way we all started together, by writing the digit 1. And now integrated 3 is closed. It all comes together. By the way, if you want to see a very quick bonus video, we have 2 updates here. Number 1, we have the year-end wrap-up. If you haven't seen the year-end wrap-up, you can click on that right now, all right? There's a link also down in the info box. Number 2, is there a road in Middle Tennessee that's actually steeper than East Hillview Drive that I featured on that one episode? Another student may have found a steeper road. If you want to click on that, you can actually investigate a little mini lesson where I went way out in the country to find maybe a steeper road. It's fun. It's a fun little lesson. All right. So you can also find the link down below. All right. That does it for integrated 3. I've enjoyed our time together.